Welcome back everyone to 3 Inquisitive Kids. In this video, we are going to be looking at divisibility rules. So first, what are divisibility rules? Well, in number sense word problems like in math, count, math Olympiad, AMC 8, there are these, so they often ask you, this number is divisible by blah 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 blah, and you're trying to find something. Divisibility rules are basically they're like patterns of like division. Here's what I mean. When a number is divisible by 3, so I'm saying that all multiples of 3 digits add up to a multiple of 3. Take 18 for example. 18's 2 digits, 1 and 8 add up to 9. And 9 is a multiple of 3. So that's like, if you look at a number and you see that its digits add up to a multiple of 3, you have a multiple of 3 right there. Another example is 54. If you add them up, it also adds up to 9. Another reason why you know it's divisible by 3. Another reason, 3 digits is 123. 1, 2, 3. Add them all up, you will get 6. 6 is another multiple of 3, which you know that this number itself is a multiple of 3 as well. Okay, so that's our 3 rule. Now 4. So for 4, you first know that 4 times 25 is equal to 100. Okay, because of that, any number's last 2 digits, so it's tens place and it's as long as, for example, I have 1048, for example. As long as the last 2 digits remain a multiple of 4, in this case that's 48. 48 is a multiple of 4. So that means that this is multiple for itself. The reason is all behind how 4 times 25 is equal to 100 because this is actually less, all the digits that are less than hundreds. So all hundreds are divisible by 4, and as long as these two numbers also are divisible by 4, then this whole number is divisible by 4. Another example for 4 would be, for example, 524. I know this because 524 is equal to 500 plus 24 in the last 2 digits. And if we know that 500 is a multiple of 100, and we know that 100 is already a multiple of 4, so we know that this is multiple by 4, and at the same time, 24 we know is a multiple of 4 as well. So I hope you know where this 5. Now this one is going to get a little simpler. For 5, you should have already noticed this. All multiples end in 5 or 0. So just this because every single time you see a number that ends in 5 or ends in 0, you know that because the next digit from that would be the tens place, and all tens is a multiple of 5 already themselves. So all we have to do is just look at the ones place and see if that is a multiple of 5 as well, and that kind of works the same way as our 4. Alright, now 6. Whenever a number is divisible by 6, you should come to know that it is divisible by 2 and 3. So what happens is that all digits sum up, so digits sum is always equal to a multiple of 3. Notice how I never said 3, I said a multiple of 3. And it is double. It's an even number, which means that the units digit can only be 0, 2, 4, 6, or 8. Now I'm going to skip 7 and go straight to 8. 8, you may notice, is just a... Now I'm going to skip all the way to 9. So 9 is another multiple of 3. Yes, it is very, very special. 3. And 9, it actually, if you ever looked at 54, or you looked at 45, 126, all those numbers, they have something in common. The digits sum to multiple of 9. So every single time if you see a number that has a digit sum of 9, then you know it is a number of 9 itself. 10, no problem. All of its multiples end in 0. Now 11, this is kind of actually my favorite one. So every single time you have, for example, 11 times 11. Okay, so in one of these 11s, how many digits are there? There's actually 2 rules to 11. I'm going to start with this one first because it's easier to understand. How much 11s are in this 111? How much ones, I'm sorry. How much ones? You would say 2. Okay, 2. So that answer would be 121. Now you're not getting it yet, so I'm going to continue with another example. 111, I increased another 11 with the digits. So now there are 3 ones in 111. Times another 111, remember this has to be the same number times itself, and it equals 1, 2, 3, 2, 1. Are you trying to get what I'm talking about? Increase the digits of ones in 111 to another one, so there's 4 ones now. 1, 2, 3, 1, 2, 3, 4 times 1 is 3, 4 ones. And that gives us 1, 2, 3, 4, 3, 2, 1. So this is what I like to call pyramid results. So this goes up in a pyramid actually, and it falls back down. So that works for numbers with just 11s, but what if there's a 11 with another number? Well, if it's 9, if the number is 1 to 9, for example, like 11 times 6, that's just doubling that digit, so 66. 11 times 0 is just 0, that's just an exception, because any number times 0 is equal to 0. But if you do it with a 2-digit number, like 11 times 21, watch what happens. So there's a 1, and then there's a 2. But what's in the middle? The middle is actually the sum of this number and this number. So that's 231. 11 times, another example, 36. The start would be 3, the end would be 6. Added together, it would be 9 in the middle. Okay, now let's try one last one. 11 times 87. So we do know that the last number is 7. In the middle would be 15, but oh no, 15, it is a higher than 10. So here's what happens. We have the 1 digit of 15, which is 5 in the middle. Then we add that extra 1 to the 8, so 957. So that's something you can keep in mind. Now moving on to 3 digits, if you do 11 times, say, 3, if you do 11 times, 1, 2, 3, watch what happens. you'll have, yep, it ends in 3 because it's the same rule as here, just that there's more digits. Then what's 2 plus 3? Okay, 5. Then there's that 2, and then over there is 2 plus 1. Another 3, then it starts in 1. Okay, ends in 1. Another example, 11 times 456. Okay, I'm going all digit by digits here. So it ends in 6. 6 plus 5 is equal to 11. 1, carry that 10 to the next place. That makes the 5 a 6. And then 5 plus 4 is 9. Okay, and it starts with 4. So this is the rule of 11. For 12, there is no distinct one actually. You just have to kind of look at, 11. First do the 11 and then plus the extra one of that number you're multiplying. So you get 12 times that. So these are all of the basic divisibility rules that I'd like you to grasp by the end of this lesson. Especially the 11. I think that's the hardest one to understand actually, especially like the multi-digit ones. But thank you for watching and seeing you next time.